Have you ever wondered, if no star had ever exploded, would we even exist today? The answer is no, because inside every cell of our body, from the iron in our blood to the calcium in our bones, all of it was born from the violent deaths of giant stars billions of years ago. In other words, we are stardust that breathes, thinks, and dreams. That journey began in the early universe, when there was nothing but hydrogen and helium. Then came the very first generation of stars. They burned brilliantly and died. In their explosions, they scattered heavy elements into space, creating enormous clouds of gas and dust. From those clouds, the sun, the planets, and eventually our Earth were formed. In this video, SolarTell will take you back in time, to witness the birth and death of stars, to discover how Earth was forged from cosmic ashes, and to realize just how deeply our existence is tied to the life cycle of the universe. Milky Way, this isn't just cold science. It's an epic story about life and death, about how small we are, yet how incredibly special we are in the vast cosmos. Backhand index pointing right if you find this journey fascinating. Don't forget to like, subscribe to SolarTell, and share your thoughts, so I'll have even more motivation to bring you more cosmic mysteries. The early universe, the first building blocks of everything. Imagine rewinding the clock. Not 100 years, not a million, but 13.8 billion years into the past. That's the moment of the Big Bang, the event that gave birth to the universe. In the very first fraction of a second, everything was chaos. Unimaginable energy, temperatures of trillions of degrees, and space itself expanding faster than we can picture. But out of that chaos, the first building blocks appeared. Fundamental particles like protons, neutrons, and electrons came into existence. They combined to form the simplest atoms, mostly hydrogen and helium, with just a tiny bit of lithium. That was all the universe had in its earliest days. No stars, no planets, no light. This period is called the Cosmic Dark Ages, a universe cold, dark, and waiting for the next miracle. Then, about 200 million years later, enormous clouds of hydrogen began collapsing under their own gravity. As the gas grew denser and hotter, something inevitable happened. For the very first time, a flame was lit in the universe. A star was born. These were the so-called population 3 stars, the very first generation of stars. They were massive, dazzlingly bright, but also short-lived. After only a few million years, they ended in violent supernova explosions, hurling heavier elements, carbon, oxygen, iron, into space. These became the raw materials for later stars and planets. In a way, their deaths were the first great gift to the universe. Without them, there would be no Earth, and no us. The birth of stars, from dust clouds to first light. Picture a dark region of space, filled with enormous clouds of gas and dust stretching for dozens, even hundreds of light years. These are stellar nurseries, the cradles where stars are born. For millions of years, these clouds drift almost motionless. But with just a small disturbance, maybe a shockwave from a nearby supernova, or even a random fluctuation, the magic begins. Gas and dust start clumping together. Gravity pulls them tighter and tighter, forming huge swirling masses. At the center, pressure and temperature rise to unimaginable levels. And then, the miracle, hydrogen atoms begin fusing into helium. This is nuclear fusion, the process that powers the stars. From that moment on, a star has truly come to life. These young stars enter what's called the main sequence stage. Here, they reach a fragile balance. Gravity tries to collapse them inward, while the pressure of radiation from fusion pushes outward. The two forces balance each other, allowing the star to shine steadily for millions, even billions of years. Our sun is in this stage right now. It has been stable for more than 4.6 billion years, and will continue for about 5 billion more. But not all stars are alike. Small, faint stars live incredibly long lives, hundreds of billions of years. Medium stars, like our sun, live for a few billion years. And giant, brilliant stars? They live fast and die young, burning out in just a few million years. You could say, a star's mass determines its fate. The bigger the star, the shorter but more spectacular its life. The smaller the star, the longer it lasts, quiet and unassuming. The life cycle of stars: birth, growth, and glorious death. When a star is born and enters the main sequence, that's only the beginning of its long story. Like every living creature, each star goes through a life cycle: birth, growth, and finally death. And it is in their death that they scatter the elements essential for life. The growth stage, a fragile balance. On the main sequence, a star survives thanks to nuclear fusion. Hydrogen in its core fuses into helium, releasing tremendous energy. This energy pushes outward, countering the inward pull of gravity that tries to collapse the star. Small stars like Proxima Centauri can live for tens to hundreds of billions of years. They shine quietly and steadily, but don't produce many heavy elements. Medium stars like our Sun live for billions of years, creating enough carbon, oxygen, and other elements needed to form planets and life. Massive stars, 10, 20, or even 100 times heavier than the Sun, live only a few million years, short but brilliantly intense. Throughout this stage, the star maintains a delicate balance. But pressure in the core keeps rising as hydrogen slowly runs out. When hydrogen is nearly gone, this fragile equilibrium begins to break down. The red giant phase. Once hydrogen is depleted, the core contracts and heats up, while the outer layers expand dramatically. The star swells into a red giant. Our Sun, about 5 billion years from now, will enter this phase. Its outer layers will expand, possibly engulfing the nearby planets Mercury and Venus. For massive stars, their enormous cores generate pressures so extreme that fusion continues beyond helium, producing heavier and heavier elements. Carbon, oxygen, neon, silicon, and finally, iron. And here's the key. Iron marks the end of the road for fusion. Fusing iron consumes energy instead of releasing it. Gravity takes over, and the star's core begins to collapse. A glorious death, the supernova. When the collapsing core falls in on itself, the energy released in just a few seconds is enough to blast away the star's outer layers. This explosion is called a supernova, one of the most powerful events in the universe. A supernova can shine brighter than an entire galaxy for days. Heavy elements like gold, uranium, carbon, oxygen, and iron are hurled into space, seeding the galaxy. The debris from these explosions becomes the raw material for new generations of stars, planets, and ultimately, life itself. We, and Earth, exist because of past supernovae. Without them, the heavy elements needed for life would never have appeared. Special endings: neutron stars and black holes. For the most massive stars, the collapsed core becomes something even more extreme. Neutron stars, only a few kilometers wide, but with 1.5 to 2 times the mass of the Sun. A single teaspoon of neutron star material would weigh as much as Mount Everest. Black holes. If the core is even heavier, it collapses completely, creating a region where gravity is so intense that not even light can escape. These remnants are among the most powerful reminders of the universe's incredible forces. Why the star life cycle matters. Every star is a vast chemical factory. They are born, live, die, and in their death, they leave behind the ingredients for planets and life. Without carbon and oxygen from earlier stars, there would be no water or DNA. Without iron, our blood could not carry oxygen. Without silicon, there would be no rocks, no soil, no solid planets. In other words, we are the direct descendants of dead stars. Milky Way, when you look at the night sky, each twinkling star is telling a story of birth, of a blazing youth, and of a magnificent death that paves the way for future stars, and eventually, for us. Backhand index pointing right in the next chapter, SolarTell will guide you through the journey of Earth's formation, from stardust and supernova explosions to the creation of our blue planet, the cradle of life. From stardust to Earth, the planet of life. If Chapter 3 was about the dazzling death of stars, now we take a step back to witness the birth of Earth, a small but extraordinary world in the vastness of space. From a cosmic cloud to the Sun. Let's rewind to about 4.6 billion years ago, in a quiet corner of the Milky Way. A massive cloud of gas and dust was drifting in space, the remains of earlier supernovae, filled with heavy elements like carbon, oxygen, iron, and silicon. Gravity pulled this cloud inward, making it swirl and grow denser. At the center, the collapsing gas ignited the sun, as nuclear fusion lit up its core. The newborn sun blasted out strong stellar winds, sweeping away excess gas and flattening the remaining material into a rotating protoplanetary disk, the birthplace of planets. Shaping the planets, Earth begins to form. In this disk, dust and rock grains began colliding and sticking together, forming larger and larger clumps called planetesimals. Over millions of years, these planetesimals merged into young planets. One of them was the early Earth. At first, Earth was nothing like it is today, a fiery world covered in magma, with little atmosphere and no water. As Earth cooled, a crust formed, and gases from volcanoes created a primitive atmosphere. But still, there was no water. So where did it come from? Water and the first ingredients of life. Some water was delivered by icy asteroids and comets crashing into Earth. Some was produced by chemical reactions deep inside Earth's mantle, released as steam through volcanic activity. Gradually, this water condensed into the first oceans. Carbon dioxide, nitrogen, and methane dissolved into the seas, creating a rich chemical environment. This was the stage being set for life, even though Earth was still a harsh and violent place. Atmosphere and protection. For hundreds of millions of years, Earth was bombarded by asteroids and comets, creating huge craters and seas of lava. But as the atmosphere thickened, it began shielding the planet from the sun's deadly radiation, stabilizing the surface temperature enough for liquid water to survive. This is when the first organic molecules appeared. The heavy elements left behind by dead stars, carbon, oxygen, nitrogen, combined to form the first building blocks of life. Earth becomes a home for life. Over hundreds of millions more years, Earth cooled further. The oceans deepened, and the atmosphere grew richer in CO2, nitrogen, and water vapor. Organic molecules linked together into more complex structures, eventually giving rise to the first single-celled organisms. This was about 3.5 to 4 billion years ago, when Earth finally became ready for life, thanks to everything the stars had done before. Without stardust, without supernovae, without heavy elements, there would be no Earth, no oceans, and no life. Every atom in our bodies is the legacy of ancient stars, and Earth's story is just one chapter in the grand life cycle of the cosmos. So when you look at a rock, a drop of water, or even your own body, remember, all of it was forged from stardust, from supernova explosions, and from Earth's 4.6 billion year journey. In the next part, SolarTell will take you through the rise of life itself, from the first microbes to complex organisms, and finally to us, stardust with consciousness. From the first organisms to humanity, the journey of life. Once Earth had formed, oceans had appeared, and the essential elements were in place, the next miracle was ready to unfold. Life itself. This journey stretched across billions of years, full of upheavals and turning points, as if the universe had carefully scripted it. The first organisms, simple sparks of life. Around 3.5 to 4 billion years ago, in Earth's primordial oceans, organic molecules combined into more complex structures. Out of this chemistry emerged the first single-celled organisms, the ancestors of all life. Tiny and simple, they carried the very first genetic codes, DNA and RNA. Over time, through copying and mutation, they gave rise to the earliest biodiversity. This is proof that all life on Earth shares a common origin, branching out like limbs of a vast tree from a single root. It was also the moment Earth began to breathe. Some of these early organisms evolved the ability to photosynthesize, releasing oxygen and transforming the atmosphere. Oxygen revolution. A planet transformed. About 2.4 billion years ago, thanks to photosynthetic organisms, cyanobacteria, Earth's appearance changed dramatically. Oxygen began to accumulate in the atmosphere, triggering what scientists call the Great Oxidation Event. This was a turning point for complex life. Aerobic, oxygen-breathing organisms appeared. the path opened for the evolution of multicellular life. And once again, it all traced back to the elements and conditions forged by ancient stars. Multicellularity and the explosion of diversity. Around 1 billion years ago, multicellular organisms appeared, ranging from tiny clusters to increasingly complex life forms. Earth became a grand stage for evolution. Aquatic creatures adapted and eventually ventured onto land. The first plants spread across continents, creating complex ecosystems. Life blossomed into dazzling diversity. Algae, insects, fish, reptiles, mammals. Every leap in evolution was the result of a chain that began with atoms inside stars, to single cells, to complex life. The arrival of humans. About 300,000 years ago, Homo sapiens appeared. We are the culmination of billions of years of evolution, shaped by heavy elements created in stars, and refined by the long story of biology. With larger brains, we developed thought, imagination, and curiosity. We began to ask questions about the universe, about the stars, the very same question SolarTell is exploring today. No creature on Earth can escape the cosmic cycle. We are stardust made conscious. Looking back on the whole journey, picture it. Stars were born from the first clouds of hydrogen and helium. Stars lived, died, and exploded, scattering heavy elements. Those elements formed the sun and the earth. Earth gave rise to oceans, atmosphere, and organic molecules. Life emerged, evolved, and diversified over billions of years. Humans arrived, gazing at the night sky, wondering about our origins. We are the living connection of the universe, proof that the death of stars was not just an ending, but the beginning of new life. When you look up at the night sky, remember, every atom in your body is stardust. Every breath, every drop of water, every grain of soil traces back to stars. And every question you ask about the cosmos is a way of reconnecting with billions of years of universal history. If you find this story fascinating, don't forget to like, share, and subscribe to SolarTell to keep exploring the universe's marvelous mysteries together. Each video is a journey through time, taking you from distant stars all the way to the very planet beneath your feet.